Welcome to part 2 of solving rational equations. So our first part was about solving ones where it was one fraction on one side, one on the other. We could simply find our cross products and then solve it to find our solutions. Now we're going to get to some more complicated equations where that's not going to be quite as easy to do. So we're going to have to find other strategies to help us solve it. So one of those strategies is using something called the least common denominator. Basically, it's looking at all of your denominators in a problem and thinking about, okay, what number or what term, because it could have numbers and variables, was the smallest thing that could be divided by all of my denominators. So what could be divided by 4x? What could be divided by 2? What could be divided by n? Well, for the numbers 4 and 2, the smallest number that could be divided by 4 and could be divided by 2 is 4. The smallest thing that could be divided by x is x, and the smallest thing that could be divided by n is n. Because 4xn could be divided by 4x, it could be divided by 2, and it could be divided by n, and everything in the denominator could be divided out. So how about the next one? 3x, 5, and 3x. Well, I like to focus on the numbers first. What could 3 and 5 both go into? Well, they can both go into 15. What can x go into? It can go into x, so 15x. So next one, 8y, y squared, and 6. Well, 8 and 6 can both go into 24. Again, we're trying to find the smallest number that we can because it keeps the numbers more manageable. What could both y and y squared go into? Well, they can both go into y squared. All right, so now let's put that into use. So now we're going to solve some equations using that skill. We're still going to have the same first step. Put parentheses around the binomials so we know that they're kind of traveling in a pack. If you see an x plus 3, it's got to be the whole x plus 3 that we're working with, not just the x or just the 3. Then we're going to do what we just practiced. We're going to find the least common denominator of all of those terms, and here's why. We're going to multiply all of the problem using that least common denominator. What's going to happen is, when we simplify it, you're not going to have any fractions left in the problem. So by using that least common denominator, it will divide out with everything in one of my numerators, so I'm only left with something in my, divide out something in all of my denominators, so I'm only left with a numerator. So now I just have a whole term instead of a fraction. Then we simply solve it like we normally would, and check for extraneous solutions. All right, so let's see that in action. So 1 over 2x plus 3/10 equals 1 over 5x. So first thing we do, look for excluded values. So we know what numbers to avoid as possible solutions. Well, what could I plug in for x in this problem that would give me a 0 in a denominator? Well, that would be an x of 0. So my excluded value is x's cannot be equal to 0. Now I look for that least common denominator because I want to get rid of all of those fractions. Well, what could 2x, 10, and 5x all go into? Well, 2, 5, and 10 can all go into 10, and x can go into x. So I'm effectively multiplying this entire problem times 10x. Well, what that really means is each of these terms are going to get multiplied times 10x. So 10x times 1 over 2x, 10x times 3/10, and 10x times 1 over 5x. But the idea is by multiplying all of them by that least common denominator, I'm treating them all equally, so I haven't changed my equation, I should be able to eliminate those denominators by doing some simplifying. So here, an x and an x could be divided out, 10 and 2 could each be divided by 2, and I would be left with 5. 5 times 1 is 5. In my middle term, I can divide a 10 out of numerator and denominator, so I'm left with 3 and an x, or 3x. And then for the last one, I can eliminate an x, and I could divide out a 5, and I'm just left with 2 times 1 is 2. Now, it's just a simple equation for me to solve. So I'm going to subtract my 5 to the other side. I'm going to divide by 3, and I get a solution of x equals -1. Then, like any good mathematician, we go back, we check our work. The key is when we check our work, you must check using the original version of the problem. You can't use your version after you got rid of the denominators or anything like that, because on the off chance you made a mistake during any of those steps, we'll never know that if we don't check it from the original. So everywhere we see an x, we're going to plug in -1. So 1 over 2 times -1 plus 3/10 is hopefully equal to 1 over 5 times -1. Well, 1 over 2 times -1 is -1/2 plus 3/10 is equal to -1/5. Well, if I write them with common denominators, this is -5/10 plus +3/10, and hopefully that's equal to -2/10, because that's what -5/10 is, or -1/5 is equal to. Well, -5 plus 3 is -2, so I'm good. All right, next one. First off, look for those excluded values. What can't x be equal to? Well, x can't be equal to 0. Then I start looking for my least common denominator. What could I multiply by to get rid of all of my denominators? Well, to get rid of a 3 and a 6, I need a 6. To get rid of an x, I need an x. So I'm going to multiply everything times 6x. So 6x times 1/3, 6x times 1 over 3x, and 6x times 1/6. Everything gets multiplied by that least common denominator. So in the first term, I can divide a 3 out of numerator and denominator, and I'm just left with a 2 and an x. Here I can divide out an x, and I can divide out a 3, and I'm just left with 2. On my right-hand side, I can divide a 6 out of numerator and denominator, and I'm left with x. Now I just do some solving. So I'm going to move my -2 to this side. I'm going to move my x to this side. And I get x is equal to -2. Now I go ahead and check it. So 1/3 plus 1 over 3 times -2 is hopefully equal to 1/6. Well, 1/3 is really 2/6. 1 over 3 times -2 is -1/6. And 2 plus -1 is 1/6. So I'm good. All right, last problem. So excluded values. What can x not be equal to? Well, x is not equal to 0, and x is not equal to -3, because I got to take care of both of those possibilities. Now I have to look for my least common denominator, and this is where it gets a little bit more complicated. So I need to get rid of an x, so I need to get rid of an x. But that x does not get rid of the x and x plus 3. Remember, x plus 3 is one whole term. If you think about the problems where we've done some simplifying, the only way to get rid of an x plus 3 in the denominator is to cancel it out with an x plus 3 in the numerator. So my least common denominator is both x and x plus 3. So I multiply everything times x plus 3. So I have x times x plus 3 times 8 over x plus 3. I have x times x plus 3 multiplied times 1 over x. And I have x times x plus 3 times 1. Well, now I can start to eliminate some things. I can simplify. I can divide an x plus 3 out of numerator and denominator, and I'm left with 8x. I can divide an x out of numerator and denominator, and I'm left with an x plus 3. For the last one, it's just multiplying times 1. So I have the whole x times x plus 3. Now it's just an equation, but now I got to do some work. So I got 8x is equal to x plus 3 plus x squared plus 3x. I can combine those like terms, and I get x squared plus 4x plus 3, and I have my 8x on the other side. So hopefully your brain immediately went to, ooh, I've got a squared term, so this is quadratic, meaning I need to factor it. Well, I can't factor it until it's equal to 0, so I need to move that 8x to the other side, and I get 0 is equal to x squared minus 4x plus 3. I can factor that into x minus 3 and x minus 1. And when I set those equal to 0, I get x is equal to 3, and x is equal to 1. Those are my two possible solutions. So I'm going to check those in my equation. So 8 over 3 plus 3 is equal to 1 over 3 plus 1. Well, 8 over 3 plus 3 is 8 over 6, or 4/3. 1/3 plus 1, well, 1 is really 3/3, so 1/3 plus 3/3 is 4/3. And I do get 4/3 is equal to 4/3. Now if I plug in a 1, 8 over 1 plus 3, is that equal to 1 over 1 plus 1? 8 over 1 plus 3 is 8/4, or 2. On the other side, 1 over 1 is 1, plus 1 is 2. So I'm good. So we use that least common denominator in order to help us eliminate our denominators, to rationalize those denominators and make them into whole terms. And then we just simply solve it like we normally would.